Rubidium oxide. Rubidium oxide is the chemical compound with the formula Rb2O. Rubidium oxide is highly reactive towards water, and therefore it would not be expected to occur naturally. The rubidium content in minerals is often calculated and quoted in terms of Rb2O. In reality, the rubidium is typically present as a component of actually an impurity in silicate or aluminosilicate. A major source of rubidium is lepidolite, K-litwoyl al-3-otin FOH2, wherein Rb sometimes replaces K. Rb2O is a yellow-colored solid. The related species NaTwoO, K2O, and CS2O are colorless, pale yellow, and orange, respectively. The alkali metal oxides crystallize in the antifluorite structure. In the antifluorite motif, the positions of the anions and cations are reversed relative to their positions in Ca(F2), with rubidium ions 4-coordinate tetrahedral and oxide ions 8-coordinate cubic. Properties. Like other alkali metal oxides, Rb2O is a strong base. Thus, Rb2O reacts exothermically with water to form rubidium hydroxide. Rb2O plus H2O 2Rb. So reactive is Rb2O toward water. Upon heating, Rb2O reacts with hydrogen to rubidium hydroxide and rubidium hydride. Rb2O plus H2RbOH plus RbH. Synthesis. For laboratory use, RbOH is usually used in place of the oxide. RbOH can be purchased for Ca. US $5/G 2006. The hydroxide is more useful, less reactive toward atmospheric moisture, and less expensive than the oxide. As for most alkali metal oxides, the best synthesis of Rb2O does not entail oxidation of the metal but reduction of the anhydrous nitrate. 10Rb plus 2Rb and O3 6Rb2O plus into typical for alkali metal hydroxides. RbOH cannot be dehydrated to the oxide. Instead, the hydroxide can be decomposed to the oxide by reduction of the hydrogen ion using Rb metal. 2Rb plus 2RbOH 2Rb2O plus H2 metallic Rb reacts with O2O, as indicated by its tendency to rapidly tarnish in air. The tarnishing process is relatively colorful as it proceeds via bronze-colored Rb6O and copper-colored Rb9 O2O. The suboxides of rubidium that have been characterized by X-ray crystallography include Rb9, O2O, and Rb6O, as well as the mixed CS-Rb suboxides Cis11O3 Rb N equals 1, 2, 3. The final product of oxygenation of Rb is principally Rb O2O rubidium superoxide. Rb plus O2O Rb O2O. This superoxide can then be reduced to Rb2O using excess rubidium metal. 3 Rb plus Rb O2O 2 Rb2O